Hello everyone and welcome back to our channel. We often talk about how caching speeds up our reads, but what about writes? How do we ensure that when we update data, both our cache and our main database stay in sync, preventing users from seeing stale information? Today, we are exploring a crucial caching strategy designed to tackle this very problem, right through caching. This strategy prioritizes data consistency above all else. So let's dive into how it works and when it's the right choice for your system. Okay, so let's start here with what is write-through caching. So what is exactly write-through caching? In a write-through caching strategy, when your application performs a write operations like inserts, update, delete, the data is written synchronously to both the cache and the underlying database before the operation is confirmed. So for example, let's just take a pin here. So let's say that we have our application, call this app, and we have here our cache, and we have here our database. We have these three components. So your application wants to update a piece of data. Say, for example, it wants to update user profile for ID 456. It sends this update requests to the cache system. Okay? The cache system first writes this update data to its own storage. Crucially, it then immediately writes the same data to the primary database. Only after the write has been successfully committed on both the cache and the database and the cache, this write operation will be confirmed. So again, only after the write has been successfully committed to both the cache and the database does the cache confirm to the application that the write operation is completed successfully. The defining characteristics here is that the cache and the database are updated in a single atomic locking operation from the application's perspective. Data is written through the cache to the database. Okay. But what are the advantages from this strategy? This synchronous dual written approach brings some significant advantages. First, strong data consistency. This is a primary benefit and the main reason to choose write through cache, because data is written both to both the cache and the database simultaneously before the operation is complete. The cache and the database are almost always in sync. This greatly reduces the chances of serving stale data from the cache on subsequent reads. If a read request comes in right after right after a write request, the cache will have the fresh data. Next, we have data durability. Since every write goes directly to the database, your data is durable, stored in the source of truth. Even if the cache were to fail immediately after write operation, the data would still be safe in the database. This provides a good level of data safety. Number three, a simpler read logic. When paired with a cache that reads data like read through cache or even cache aside, the read logic can be confident that if data is in the cache, it's likely up to date, assuming no other processors are modifying the database directly without updating the cache. Lastly, reliability. So applications can rely on the fact that once a write is acknowledged, the data is safely stored in the persistent database and is also available for fast reads from the cache. Okay, let's talk about what are the disadvantages and considerations of write through cache. Number one, increased write latency. This is the most significant drawbacks because every write operation involves two separate write steps. One to the cache, which is usually fast in memory, and one to the database, which is often slower, involving disk I/O operations. The overall latency for write operation is higher. The application has to wait for both writes to complete before it can process. This can slow down write-heavy application. But two, potential bottlenecks at the cache. The cache itself can become a bottleneck if it can't handle the combined load of serving reads and performing synchronous writes to the database for every update. Number three, resource intensive. Writing to two systems for every update consumes more resources, CPU, network, compared to strategies where writes might only go to database or only to the cache initially. Number four, full cache scenarios. If the cache is full and an item needs to be evicted to make space for the new write, the eviction logic adds another step to the write operation, potentially further increasing latency. Okay. Next, when is write through cache a good fit for your system? First, again, so given its characteristics, write through cache, caching is particularly well suited for specific types of application and data. Number one, applications requiring high data consistency. If it's critical that reads always reflect the latest writes and stale data is unacceptable, write through cache is an excellent choice. Examples include financial system, inventory management, or any application where data accuracy after write is paramount. Number two, read heavy workloads without moderate writes. While it adds latency to writes, if the number of reads far outweighs the number of writes, the benefits of having constantly fresh data is in the cache for those numerous reads can justify the slower write performance. Data that must be durable immediately. If the application cannot tolerate any data loss for writes, ensuring every write goes directly to the persistent database as write through does, it's quite beneficial. Now, lastly, when paired with read through, as mentioned earlier, write through cache and read through cache often work very well together. Read through cache handles loading data into the cache on a miss, and write through cache ensures that data already is in the cache, and it is reliable and it's not stale data. Okay, the write through cache is not ideal for first write intensive application. If your application performs a very high volumes of writes, the increased latency of the dual write operations can become significant performance bottleneck. But two, applications where eventual consistency is acceptable. If your application can tolerate a small delay before reads reflect the latest writes, other strategies like write around or write back and write back might offer better write performance. Number three, systems aiming for lowest possible write latency. If minimizing write latency is the absolute top priority, the synchronous database write in a write through cache will be disadvantaged. Okay, so in conclusion, write through cache is the consistency champion among caching strategies. It ensures that your cache and your primary database are kept in close synchronization by writing to both simultaneously. While this produced higher latency for write operations, the benefit of serving constantly up-to-date data from the cache for subsequent reads makes it an inventable strategy for applications where data integrity and freshness are non-negotiable. It's all about making the trade-off between write performance and data consistency. So yeah, that's it for this video, and see you in future videos.